All right, Algebra 2 people, we're going to take a look at section 1.3 today, which is modeling with linear functions. There's several things that we're going to take a look at. First is being able to write an equation of a line just with given 2 points. And then another thing is talking about a line of best fit and the correlation coefficient. We're talking about regression. Let's take a look at our vocabulary. First off, we have line of fit, and that's when data in a scatter plot shows approximate linear relationship, and then you model with a line of best fit. When you're looking at a graph or you're looking at a plot of points, what you're trying to figure out is, can you draw a line that goes through the data, or does it look like the data is linear? So where you can draw a line that's pretty close to going through all the points. So for example, right here, if I draw a little table, if I draw a bunch of points that look like this, I would say it would be safe to say that I'd be able to draw a line that kind of goes through those points there, and that we would be able to draw a line of best fit. As opposed to if I have data all around like that, realistically, it doesn't look like a line that would be formed. It just looks like a big old blob. So our next term, we have the line of best fit. So that is the line that lies as close as possible to all data points. It's not going to be perfect unless it's an actual linear like growth or regression, where it's going up linear or it's going down in a line. So if not, that's when we have to figure out, well, what is the line of best fit? Now, to do that by hand, it's pretty tedious. Therefore, there are calculators that will allow us to try to figure out, well, what is the line of best fit? Picking 2 points in the data and trying to first estimate, well, what is the line that goes through most of them? And then using a regression calculator to help us along the way. So that takes us to our third term, which is the correlation coefficient. We use the variable r, and if r is near 1, that tells us that the points are close to the line with positive slope. If this value r is near -1 or close to it, then the points are close to the line with a negative slope. And then use a regression calculator to find r. So you don't actually have to do all the hard mathematics behind it, because you will be just having to use a calculator. And the state tests, oftentimes they do have you practice using a regression calculator, and I will show you how to do that using Desmos today. So let's start off first writing the equation of a line. That right there is some stuff from Algebra 1. Okay. So it shouldn't be, hopefully, anything too entirely new for you. And let's take a look at this right here. Okay. So writing equation of a line, if you're given the slope and the y-intercept, then you can just use the equation y equals mx plus b. However, a lot of times you may not be given the slope and the y-intercept. You may only be given 2 points. And so if you're given 2 points, then what I would typically use is the point slope form. Okay, so definitely use this right here equation when given 2 points. All right, make sure you memorize it. That is an equation that is not given to you on like the PSAT and SATs, but oftentimes they do ask you to find it, find an equation of a line. So definitely an equation that is used quite often. Now, can you use y equals mx plus b to find an equation of a line if you're given 2 points? Yes. However, I like using point slope form because it automatically gives you your answer in slope intercept form. So why do the extra work when you don't have to? So that's why right here, when given 2 points, the last little piece, it mentions, all right, use the slope formula to find m, and then use the point slope form with either given point. All right, so those are your rules or steps in writing an equation of a line. Let's take a look right here. Go down. How do we find a line of fit? Okay, they're saying create a scatter plot of the data. So you're going to be given a table, and from that table you're going to be, plotting your points. And what they're saying is you want to sketch a line that appears to follow the trend. So it looks like this is an upward trend. So you're going to draw a line. Now, it's not any arbitrary line. You want to try to find a line that goes through 2 of these points, and also is very close to the rest of the points that may not be on the line. So you're going to have to eyeball it, but you need to be able to choose 2 points. Okay, so step 2, sketch the line, and there should be about as many points above the line as below it. Step 3, choose 2 points on the line and estimate the coordinates of each point. Well, usually you don't have to estimate the points, but you would choose 2 points that are on the line. Hopefully, you choose 2 points that are actually from the table when you created your line. It does say the points do not have to be the original data points, but I think usually you're better off doing that instead of trying to make up points. And then step 4, you write an equation line that passes through the 2 points from step 3. So part of it, what we would probably end up doing is using the regression calculator to help us come up with our equation. All right, moving along. So it says, use the graph to write an equation of the line and interpret the slope. So I guess a few things. If you forgot right here, equations that you should know, I'll put one up right here. Slope equation. We use the variable m, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Plugging in the 2 points, that will help you get your slope. Okay, so this is definitely step 1 of the process of writing the equation. Step 2, use point slope form. So by doing that, all you need to do is plug in the slope that you found in step 1. You plug that into the point slope form equation, and then you take one of the points from the data and you plug it in and you solve for y, and just like that you'll be able to get your line equation of the line. So let's take a look right here on number 1. So step 1, let's find the slope. Okay, and once again you could start labeling things. We could put like x1, y1, x2, y2. All right, and from there, let's go ahead. I've got 51 minus 50 divided by 10 minus 0. And so right here, I end up with 1 over 10. And that is your slope. So we have the slope. Step 2, we use our point slope form. It goes y minus y sub 1 is equal to m times x minus x sub 1. I'll plug in my slope right here. So this will be 1 over 10. And the y and the x, we don't plug anything in for. Okay? What we're going to plug in is x1 and y1. So honestly, you just need to choose any point, any one of these 2 points as x1, y1. You might as well choose the easiest one here, where the numbers are small, or you don't have to do any crazy calculations. And for me, hopefully it makes sense that 0, 50 would be the easiest one to use. And I'll show you why. Because right here we have 1 minus 50, and that's equal to, and then we'll put parentheses 1/10, and then times x minus 0. And you really don't have to do any work with x minus 0, right? X minus 0 is going to be x. So knowing that, that's why I chose that point as opposed to 10 and 51. However, you will get the same answer either way as long as you do the work correctly. So lastly, what we need to do is go ahead and simplify this. And I'll go ahead, we have y minus 50 is equal to, and then I'll distribute the 110, and it'll be 110 times x, or 110x. You may also see it as x over 10, same thing. And then lastly, let's get y by itself. We'll add 50 to both sides, and we get 110x plus 50. And this right here is your equation of the line. Okay? Easy, right? Let's do another one. We'll take a look at number 3. So step 1, let's find the slope. I'll go ahead right here. I'll put this as x1, y1, x2, y2. All right, so 95 minus 85, divide that by 20 minus 10. And then we'll end up with 10 over 10, which equals 1. So my slope right here for this line is 1. Step 2, we use the point slope form. Which one of these 2 points do you want to use? Like I said, I like small numbers, so how about 10 and 85? You could choose 20, 95. That's perfectly fine. So we have y minus y sub 1. The point right there for y1 happens to be, should be 85, and that's equal to your slope of m, and slope is 1 in this problem, so that makes things a lot easier. And then we have x minus, and then let's go ahead and plug in x sub 1, which will be 10. We'll simplify things out. We got y minus 85 is equal to, we could distribute the 1, but remember that's the identity property. It'll equal itself. So we'll end up with x minus 10, right? Distributing 1 times x is x, and 1 times negative 10, negative 10. So lastly right here, we'll go ahead and get y by itself. We'll add 85 to both sides, and then y is equal to x, and then minus, or plus, sorry, plus 75. If you look at the graph, it all works out nicely. Let's start off right here. It's less than 80, where this point would be. That's my y-intercept. And that's 75 right there. So that would be 75. That looks like it's in the right spot. If I were to go up 1 to the right 10, now, or sorry, my slope is actually 1. So going up 1 to the right 1, up 1 to the right 1, you'll see it looks like that is the slope of this line. So there you go. 2 steps in finding an equation of a line. First, find the slope. If that's not given to you, then second, use point slope form with one of the given points to find the equation of the line. All right. Next up, it says the cost of parking in a parking garage in Chicago is represented by the equation y is equal to 15x plus 20, where y is the total cost in dollars and x is the time in hours. The table shows the total cost of parking the parking garage in Denver, which city's parking garage charges more per hour, and how many hours would both cities cost the same. A lot of stuff going in here. First off, we've got to figure out, well, what is the equation of a line of what's going on in Denver? Okay. Now, remember, if things are linear, it's going to have a consistent growth or a consistent regression. Okay. You'll either add the same amount each time or subtract the same amount in each time from your data. So let's double check right here. If I look from 43 to 51, that's plus 8. 51 to 59, plus 8. And 59 to 67, that's also plus 8. So see, there's that consistency right there. For every plot or every point, it's going up 8. And if I look at my values of x, it's going up plus 1 each and every time. So that tells me that this is linear. All right, so the table shows the total cost to park in the garage. Let's figure out what our equation is. Well, how do I do that? Remember, these are points if we were to plot them. Okay, if we were to graph things out, those would be plots to the point. So I can go ahead. Step 1, let's find the slope. I'll go ahead and say this is 0.1 and this is 0.2. So y2 minus y1, divide that by x2 minus x1. And so 51 minus 43, that's 8. And then we get over 1. Slope is 8. Step 2, let's find the point. Let's find the slope, or sorry, the actual equation using point slope form. And we can use any one of the points here. I'll choose the first one since the numbers once again are smaller. So y minus y sub 1, that's going to be 43, is equal to m, which is our slope, which we just found, and then we have x minus x sub 1, which is 2. All right, so we have a little bit of work here. We got y minus 43 is equal to, and then let's distribute the 8. I end up with 8x minus 16. We'll go ahead and add 43 to both sides, and then y is equal to 8x, and then we have right here plus 27. So this is the equation right here for Denver. So a few things they want to figure out. Which city's parking garage charges more per hour? So let's start off right here. For Chicago, the Windy City, which is their nickname, we got y is equal to, well, remember, x is representing hours, so how about we go ahead and we'll plug in 1 for the hour and then solve our equation. So in Chicago, 1 hour right here, 15 plus 20, that right there is equal to 35. And that's how much it costs to park 1 hour in Chicago. Next up, we have Denver. They call that the Mile High City. And then let's go ahead, we'll use our equation, y is equal to 8 times 1 plus 27. And that right there happens to equal, let's see, 35 as well. So which city parking garage charges more per hour and by how much more? It looks like it's the same, at least to start off with, right? But then as you start plugging in more numbers, you'll realize otherwise. So, well, first off, how much do they charge per hour? It looks like it's going to be Chicago, right? Because first off, we look at the slope. That's how much every hour is going to be charged. That $20 right here, we could think of that as like a service fee, or just to go in there and park, you're going to have to pay $20 and then $15 an hour. At Denver right here, you're going to have to just figure out, okay, to park is 27 bucks. However, it's only $8 an hour. So it seems like a better deal at first, right? So going back, which city's parking garage charges more per hour? Hopefully we realize that that is Chicago, okay? Chicago charges more. And then right here, it says the next question is after how many hours would parking in both cities cost the same? Now, actually, the easiest way to solve that is if I have these two equations, what we would end up doing right here, okay, we have this equation for Denver. We have the equation right here for Chicago. And they're saying, when will it be the same in both cities? See, what we can do is use the substitution property or the method. We can set both of these equal to each other, right? Because they both have y, and that'll allow us to solve for x. So if I take the two equations, I set them equal to one another, and if they're equal, that's when things are the same, right? So that's why the best way to solve this is by actually, setting them equal to one another. So let's go ahead right here. Let me solve for x. We could subtract 8x to both sides. 15 minus 8. That right there gets you 7x. We could subtract 20 to both sides, and we'll end up with equal to 7. And x is equal to 1. All right, so how many hours would parking be the same? Only after the first hour. And then I actually showed you that right here in the beginning. So only after the first hour is parking the same. After that, which one would pay more? Definitely Chicago, because you're paying $15 an hour after that. Okay? The last part right here. It says, use a linear regression feature on a graphing calculator to find the equation of the line of best fit. Okay, and then interpret the correlation coefficient. So if I look at number 5 right here, we have our data. And I want you to think, can I draw a line that really goes through most of the data, most of the points? And it's fairly close, tight, compact. Number 5 definitely does not look like that's the case. So let's go ahead. What I'm going to do is go to Desmos, okay? And I'm going to take all these 5 points right here. And I already right here plotted the 5 points in my table. You were saying, how do you get that? Add item, table. And then you'll see X and Y, and then you can go ahead and start plugging things in. Okay? So I went ahead and already did that. Save us some time. But I definitely recommend you practicing this. Now, the next part is using an equation. And by using this equation, it's pretty much similar to using y equals mx plus b, slope-intercept form. However, Desmos will calculate it for you. In order to do that, in this second box or line right here, let's go ahead. I'm going to press Y. We have to go ahead and make sure that the equation knows to pull data from Y1. So in order to do that, you press Shift and the line button. That's probably to the right of 0 on your keypad. And you can see that the cursor is now subscript. And I'll put in a 1 right there. In order for us to bring the cursor back up to its normal position, you have to press the right arrow. Now for the next part, we're not going to use the equal sign. We use the tilde. So you press Shift, and then the button that's above the tab, and that's your tilde button. Next up, we've got M, X, okay? And now we're going to use data from X1, the first point. So we're going to do the same thing again. I'll use Shift, press the line, and press 1, and that gets me my subscript. And then we're going to go ahead and put plus B. So there you have it, Y equals, or Y sub 1 tilde mx sub 1 plus B. If you can't get to it, once again, listen to the steps that I gave you. All right, and you should be able to come up with it. Or go back on Desmos. If you type in linear regression calculator, they'll give you the equation and give you the exact buttons that I just told you to press again. So now you can see that this is the line of best fit that works. You can see two things here, r squared and r. But what I care about is r, which is your regression. It's this number right here, negative 0.0747. If you remember, I said that if your value of r is close to the 1 or negative 1, then that line is best fit, and that is the line right there. However, you see that it's not even close to point. It's not even close to 1. It's 0.07. So, and you can see the line. It doesn't even look like it's going through all of this. This data looks more like close to a quadratic. It's not, but I would say it's more U-shaped than anything else. So there's R. And what I care about the most right here is this, the parameters. Because this right here is the slope of that line, and B is your y-intercept. So if I were to solve number 5, your equation right here on number 5 would be y is equal to 0 or negative 0.078125 x plus 3.25. And all of that is coming from right there. Okay? So that's why the regression calculator, it gives you all the information that's necessary to come up with your line. Let's do one last one right here. We'll do this over. Press the table, and let's do number 7. Okay, so I'm going to go ahead and plug in points from number 7. We have the first point is 2, 2. Then we have 4, 3, 6, 4, 8, 5, and the last point right there is 9, 6. So there you have the points. It looks like just what you had in our student journal. So next step, let's come up with our equation. We had to put it down so that Desmos knows what to calculate. So y subscript 1 tilde, remember m x subscript 1 plus b. And there's your line of best fit. Look right here. In our equation, r is very close to 1. It is almost exactly at 1. Now, it's not going to be at 1 because you can see that the line right here, it does not exactly go through all the points like exactly because it's not linear, but it's very close to it. So that is depicted right here by r. Now, what exactly do they want as the answer? Remember the equation. So let's go ahead. Remember, we have slope right here as m and our y-intercept. So for your equation of this line of best fit is y is equal to 0.54878 x plus 0.817073. Now, you probably only need to round it to the nearest like hundredth, but since they gave us all the data right there, I decided to put it all in. And there's your equation of the line. And you have to use Desmos to be able to do that. All right? So there you go, section 1.3.